Pre-algebra, lesson 95, variables on both sides. What they're referring to is both sides of an equation. So in the past we've solved pretty simple equations, kind of like right here, number 17, negative 9x minus 4 equals 5, right? One variable referring to the letter x. Now what happens if I put two variables and they're on opposite sides of the equal sign? Well, we just have to remember our goal, which is to get the x all by itself. Now when there's two or multiple x's, we need to get them all on the same side of the equation. So let's go ahead and practice this on our work paper. None of the rules of equations are changing. We just have to remember our ultimate goal, get all the x's on one side and away from every other number, and then we will be just fine. Okay, now you'll see I've written down the problem twice. This is to prove a point. Because inevitably what the first question that a lot of people will always ask is, does it matter which side of the equation I put the x on, right? Does it have to be on the left side? Does it have to be on the right side? The short answer is no, but it's often hard for people to understand without actually seeing it worked out. So let's go ahead and solve this equation 2 times. So I'm going to fix this plus sign because it doesn't look like a plus sign. And none of our rules of equations are changing. We just have to remember I need to get all the x's on one side. So we'll go ahead and start by moving this x over. Remember, I'm going to start with PEMDAS backwards. So I'm going to do addition and subtraction first. So the opposite action now of this x, since it's a positive number, is going to be to subtract, right? Because subtraction is the opposite of addition. So I'll go ahead and subtract x over here. Right, I'll put some dotted lines for the center of my equation, and let's go ahead and rewrite it. So here I've got 3x minus x. This is my addition of like terms rule. So 3x minus x gives me 2x plus 3 does not change, and then x minus x cancels because 1x minus 1x is nothing, right? Negative 5 does not change, so that just gets copied down, and I cannot forget my equal sign. Great. So now I've gotten all the x's on one side. And what happens is when you move them all to one side, you end up with only one x. It's great. There's not two of them anymore. And this looks just like the older problems that we were solving. So let's go back to our 3 rules all over again. Start with PEMDAS backwards. Now I need to get the 2 and the 3 away from the x. Since I'm using addition and subtraction first, I'm going to get rid of the positive 3. And the opposite action of plus 3 is minus 3. So once I do the opposite action, I need to make sure that I do it to both sides of the equation. And then I simplify. So positive 3 minus 3 cancels. 2x just comes down and becomes 2x. I copy the equal sign. Negative 5 plus negative 3 is negative 8. Now I do the whole thing all over again, but for the last step. And the last step is just going to get rid of the 2. Since it's 2 times x, the opposite action is to divide. I'll do that with a fraction. Negative 8 over 2 reduces to negative 4, which means that x is equal to negative 4. Final answer. Okay, now, would that still have worked, and would I have gotten the same answer if I moved the x's to the right side of the equation? So, let's rewind time. We'll go to alternate reality universe, and we're going to put the x on the right side instead of the left. So before, how I moved this x over to the left, I'm going to move these 3 x's all over to the right. So the opposite of positive 3x is minus 3x. Okay, let me put my... I'll go ahead and do that to both sides of the equation. 3x minus 3x cancels. I still have a positive 3 there. Copy my equal sign. 1x minus 3x gives me negative 2x. The minus 5 does not change. Still there. Now I have to move the negative 2 and the negative 5 over to the other side. So let's go back to our rules all over again. Instead of moving the negative 2, I'm going to move the negative 5 first because I'm using PEMDAS backwards. The opposite action of negative 5 is positive 5. Right? So I'm going to add 5 to each side. And that cancels. This comes down and just becomes negative 2x. Equal sign copies. 3 plus 5 is positive 8. Okay? Now the final step, division. I got to get rid of that negative 2. So I'm going to divide by negative 2. Remember, even if it's a negative, you still, even though it's a division, you still have to divide by that negative, okay? So the negatives cancel, the 2's cancel, I'm left with x on the right side. The left side, if I do divided by negative 2, 8 divided by negative 2 gives me 4 over negative 1, which is the same as negative 4. So I still get x equals -4 or -4 is equal to x. All right, so you get the same answer either way. That's how we deal with variables on both sides of an equation. If you guys have any questions, let me know on Moodle, and I will see you in class.